Here is the third video going through stoichiometry, limiting reagent, or limited reactant, theoretical yield, and percentage yield. So number 3, the burning of 18.0 grams of carbon produces so much carbon dioxide. What is the theoretical yield? And calculate the percent yield. So the first thing we need is the chemical reaction here. Notice that's already balanced. So we were given 18.0 grams of carbon, right? We want to see how many grams of carbon dioxide we would get theoretically if we got everything we were supposed to get. So I'm going to change grams of carbon into moles of carbon. And I'm going to use the coefficients of the balanced equation to convert from moles of carbon to moles of carbon dioxide. And then for moles of carbon dioxide, using the molar mass, I'm going to get to grams of carbon dioxide. So if I go ahead and calculate that, my theoretical yield would be something like, I think I'm going to call it 66.0 grams of CO2. Well, if I only produced 55.0 grams, then my percent yield, because this is theoretical, right? This is according to the equation, but this is what we got in the experiment, so 55 over 66 times 100. So something on the order of 83.3% yield. Okay? Number 4, we have to write this equation. So we have HCl going to chlorine gas and hydrogen gas. So to balance that, I end up putting a 2 here. We're given 25.8 grams of HCl. And we want to know how much chlorine is produced, right? Now we're calculating it. It'll be theoretical. So I have to change grams of HCl to moles of HCl using the molar mass. I have to go from moles of HCl to moles of chlorine gas using the coefficients of the balanced equation. And then I take the mole of chlorine gas and change it into grams using the molar mass. So it turns out that I should have theoretically gotten 25.13 grams of CO2 if I only produced 13.6. So my actual is 13.6 over my theoretical times 100. I got about 54.12% yield, right? I only got 13.6, and I calculated 25.13 as my theoretical. All right, number 5 says we can use this equation, and we're going to reclaim silver metal from silver chloride. But it only has, it only has this 94.6%. So we have to calculate the theoretical first, AgCl. We're going to go from AgCl, from grams of it, to moles of it using molar mass. And then from moles of AgCl to moles of silver using the coefficients of the balanced equation. And then from moles of silver to grams of silver using the molar mass. I guess I don't really need that last line. If I calculate it, I'll get a 75.3 gram theoretical yield. But I only have a 94.6% yield. So I'll take that 73.3 times 0.946, and this tells me that from this I will probably get something like 71.2 grams of silver. Okay, basically we're reclaiming silver. All right, 6. It wants to know how much magnesium oxide we will produce if we have excess carbon dioxide and so much magnesium. Excess, all that means is I have enough carbon dioxide such that every bit of my magnesium metal will be used up. So I start with that 42.8 grams of magnesium metal, and then I change it over to moles of magnesium metal, right? And then I go from moles of magnesium to moles of magnesium oxide using the coefficients of the balanced equation, and I go from moles of magnesium oxide to grams using the molar mass. We calculate this, we get 70.97 grams magnesium oxide. Note that I have not been worried about sig figs. You will need to worry about sig figs, right? Now, this is theoretical. So if I only have an 81.7% yield, I'm going to multiply by 0.817 and find out that I would have 57.99 grams of magnesium oxide. All right? All right. Now these are simple and get more complicated as we go along. It says calculate the number of moles of hydrochloric acid produced from 10 moles of hydrogen. So I do. Notice I only need to go moles to moles. So 10 moles of hydrogen. Use the coefficients of the balanced equation. 1 mole of hydrogen for every 2 moles of HCl. So I end up with 20 moles of HCl. All right? Now the next one, same thing. I'm going from moles to moles. So if I need to form 14 moles of that iron chloride, I'll just use the coefficients of the balanced equations. For every 2 moles of the iron chloride, I needed 3 moles of the Cl2. So if I did 14 times 3 divided by 2, that's 21 moles of Cl2 would be required to form this many moles of iron oxide. Number 3. Now, I'm going to need to get to grams on one of them, but I'm starting with moles of nitric acid. So 2 moles nitric acid, which is NO, and I need to go, using the balanced equation, I know that for every 2 moles nitric acid, I get 2 moles of nitrogen dioxide, don't I? 2 and 2. But they want to know the grams of nitrogen dioxide, so I need to go from the moles of NO2 to the grams using the molar mass, right? And I came up with 184.04 grams NO2. All right? All right, number 4 says calculate the mass of oxygen produced from the decomposition of this mass of potassium chlorate. So 75.0 grams, right? Potassium chlorate. So I have to go from mass to mass, but I need to go through moles. So I first figure out the molar mass of potassium chlorate, 122.5 grams in 1 mole of it, ClO3. Then I have to go from moles, 2 moles of the potassium chlorate, 3 moles of oxygen. Those are the coefficients of the balanced equation. And they want to know mass of oxygen, so I'm going to say 1 mole of the O2 is 32 grams. So all my units cancel, and I'm left with grams of O2, and I came up with 29.38 grams of O2. Not bad, right? Seems like we kind of do the same thing over and over. Calculate the mass of silver needed to react with chlorine to produce 84 grams of silver chloride. Well, I went back in our notes, and we actually had used this equation in the other direction. So 2 moles of silver plus 1 mole of chlorine gas will give us 2 moles of silver chloride. All right, we're starting with 84 grams of silver chloride. All right, I need to go mass to mass, so I've got to go through moles. So 143.32 grams of silver chloride is 1 mole of silver chloride. Then for every 2 moles of silver chloride, I get 2 moles. I need 2 moles of silver, right? And they want to know how much the mass of the silver I need. So for 1 mole of silver, the molar mass is 107.87 grams. So if I do that calculation, it shows that I need 63.22 grams of silver to produce 84 grams of silver chloride. Okay? Let's look at 6. How many liters? Now, 1 mole is the same as 22.4 liters for any gas at STP, right? So that's what we're introducing now. So how many liters of carbon monoxide at STP are needed to react with 4 grams? I gotta make sure I did this right. Oh no, 4.8 grams of oxygen gas. So 4.80 grams of O2. Well, I gotta get to moles, right? Common theme. 32 grams of O2 is 1 mole of O2. Then I need to get to moles of carbon monoxide. 1 mole of O2 for every 2 moles CO. Those are the coefficients of the balanced equation. And then I know for every 1 mole of CO, because I'm at STP here, it is 22.4 liters. So I will end up with liters of CO gas. If I do the calculation, I end up with 6.72 liters of carbon monoxide. All right, number 7. Now we want to know the numbers of liters of oxygen gas needed to produce this many liters of dinitrogen trioxide, which is that. So I'm starting with 15 liters of the N2O3. All right, I don't even need the molar mass here. I can go right to moles using this 22.4 liters per 1 mole of this. Then I go from moles of N2O3 to moles of oxygen gas, and then from moles of oxygen gas to 22.4 liters of oxygen gas, right? Liters cancels, moles, moles. I'm left with liters. I get 22.5 liters of oxygen gas. Okay? I'm going to stop here, and I will do the last video on the 4.4 worksheet.